Hello, this is Mr. Huebner, and in this video I want to talk to you about profile diagrams. So earlier, a couple of days ago in the lessons, we were going over topographical maps, how to actually interpret and read a topographical map, although we didn't have necessarily the opportunity to make a topographical map out of data points because it's too difficult. Not everybody has a printer, and quite frankly, nowadays we just put data points into a computer and the computer does it for us. So as long as we know how to interpret what the contour lines mean, how to figure out the contour interval, and then also estimate the maximum height of a mountain, then we're pretty good. So going over profile diagrams, again, since we're doing this all digitally, I did find a resource that does it digitally, although it also kind of does it for you, which is kind of a bummer. So I will post a practice sheet that looks kind of like this sheet right up here. If you are a pen and paper type of person, just want to practice along one of those, you're welcome to do that. I know not everyone has a printer, so I'm not going to make you do that, just if you want to, because they're pretty fun. So the website that we are going to be on is Virtual Labs and Analysis of Contour Maps. There's a procedure, so you click right here under Procedure, and it has a whole slew of directions. You get lost, you can go right there. You can open up a second window, so you can have a simulation on one window and procedure on the other. Although it's pretty self-explanatory, you just kind of click Next, Next, Next. All right. So here is the simulation. We have contour map 1 and 2. You need to do both of them, and once you've completed them, you must take a screenshot of each one, and then you can post it to a Google Doc, and you can share that with me, or post it on, preferably post it on Google Classroom. All right, so we'll start with contour map 1. Got this, draw profiles along A and B. So we got right here, we're going to draw a profile. And right here. First of all, what is a profile? First of all, a topographical map is a bird's eye view. You're in an airplane. What does the terrain look like? Well, it looks like a topographical map. So what is a profile diagram? A profile diagram takes a path in that topographical map and it makes it a side view, or like a profile. Like if you're in art, you got a profile picture. It's the side view of your face, typically. So we're taking a bird's eye view and we are making it so that it's from our view on the ground. That's what it's doing. So we got A to B and C to D. We want to see what does that look like from the side, a side view. All right, so I'm going to click the next arrow and, oh, okay, there we go. Oh, it's moving. Identify the lines. Oh, we already did that, but virtual simulation is doing that for us. Hey, we get to get virtual paper. All right. So what you do is you normally, on a piece of paper, you would take a straight edge sheet of paper and you'd place it right onto this line and you'd mark all the different lines where you have contour lines. So we get paper. Oh, there's our paper, and we're going to mark the points, and it marks them exactly like I was saying. And there's our data points. So point A is, they went away. Okay, well, point A is at 300. Point B is, oh, counting the intervals, we got 300 to 400. That makes it tricky. So it's probably like 333, 366, and then the 400. All right, let's get paper again. Let's do the bottom one. Oh, okay. Sorry, this thing was in the way. So it's actually 300. And then this is connecting right here. It's 400. And then it's 500 and then 600. Okay. That's where these numbers are coming in, where we got A's Okay, we're on the second one. Yeah, A is 200, B is 300, 400, and then D is 500, and then E is 500 again because it's the same contour line. And then we're going downhill. So it's 400, 300, 200. All right, a little tricky because we got that little ruler in the way, blocking things, making it a little confusing. All right, so we go to the next one. How many geological cross sections are taken in this map? And I forgot to turn my photographic memory on, so don't worry about that. Let's just say, you want to say 3? Okay. Okay, it was 2. All right, plot X, plot Y, and then points on X-axis, points on Y-axis. Look at that. That's the nice thing about that. You don't have to graph it yourself. It creates the graph right there for you. And then you press Next. And this is from our first, our one that was on the top, A to B. And we are now going to graph it. And I don't have my data points, but there they are, the data points. So we've got A is 50 and 300. All right. So I just click it. See, the nice thing about this is you really don't have to know what you're doing. You just click it and it does it for you. You do kind of understand where it's coming from. We got 50s between 0 and 100, and that's my X. And Y is 300, which is right up there. So let's try this one. 160, 400. 160 is kind of in between 100 and 200, and 400. It should be right there. Let's see if I am right. Yes. 240 and 500. 240 and 500 should be right there. Boom. Let's put the rest of them in there. Look at that. So and these marks are coming right from here. So if you're actually doing it on paper, all right, I got to figure out, all right, I, where is I? It's 930, 300, 930, 300 is probably right there. And I would mark it. And I have to make it in line with my ledger mark right there. And then J is in line with this mark. K is in line with that mark. Again, it's digital. It's not the true experience, but we'll take what we can get. All right, so I plotted them all, and then we're going to have to connect them. And I believe that's what the next thing is. And then join the points. And they're being joined. All right, how many dotted lines are identified along line A and B? How many dotted lines? So, let's see, we got 1, 2, 3, 4. It's kind of hard to answer it when it's in the way. I don't know, let's just say 16. Okay, it's 14. Okay, next one. All right, so this is the bottom one. We're going to do the same thing. Find the coordinates. All right, and how do we get the x coordinates? Really, again, you get it from these ledger marks. So it's kind of estimated. It's about 50. That's about 150. And this is about 250-ish, 260, and that's where we got that. These numbers are your contour elevation lines. All right, so I'm going to plop them all in. Computer's kind of doing it for us. Click on, okay, next. And then plot the y, and then we're going to join the points. All right. And that's it. We got graphic. So I'm going to screenshot this. I'm going to screenshot that. This was my original. So everyone's going to have the same thing for that. So just how do you screenshot it? I think it's like, you guys know how to do that. If you have questions on how to screenshot it, just send me an email. I'll have to do a tutorial and figure it out myself. I always do the snippet tool. So if you have the snippet tool, that's my favorite one. You just click on new. Oh my gosh. There we go. Interesting. So the snippet tool doesn't work when I am making a video, but essentially that's what you do. You select it. It creates a nice little picture. You can then copy and paste it right into a Google Doc that you create. And actually I'll create a standard Google Doc that's just blank for you to place it in and then turn it in. And we can be good to go on that. So once you're done with that, there is Contour Map 2 that you can work on, and this is essentially the same thing. It's just a different map and you have a different path. So that's essentially it. That's making a profile diagram from a topographical map. Alright, so if you have any questions, feel free to email me, Facebook me at Instructor Huebner, or send me a comment on Google Classroom. Hope you have a great evening, morning, or afternoon. Have a good one.